Several months ago, I was sent an extra PCB board for the SC131 single board computer, manufactured from a design by Stephen C. Cousins of Small Computer Central, and utilizing RomWBW software, a project by Wayne Warthen, including the works of many others. The truth of the matter is that I was not looking for another single board computer, and although I did not have the kit version, I had most of the components on hand and could always use the soldering practice. As I started looking into his other designs on the site and on Tindy, I started down a rabbit hole that I may be following for a while. I highly recommend looking at his various projects, and I will provide links in the notes. Although he does sell kits, he also provides the PCB layouts and excellent instructions on the website, so that you could get the board manufactured yourself, and as I did, procure most of the parts from my junk boxes and a few remaining components through DigiKey. So I will get right to it. We will start with the components that stick up the least from the board and work our way up to taller components. We will start by identifying and installing 12 resistors. As I insert my components, I will use painter's tape to hold them in place. Next, we need to identify the locations to fit and solder in 7 ceramic capacitors. Don't forget that 100 nanofarad capacitor hiding in the middle of the board. Now, with the resistors and capacitors soldered in, we will move on to placing the next components, the dip sockets. And again with the sloppy painter's tape job, holding the sockets in. After tacking in 2 pins of each socket, I go around the board, inspecting each socket, melting the solder and pushing in the socket so it seats perfectly. My music to solder by selection for this portion of the build was Stick's Pieces of 8. Obviously, I stripped all audio out so that I can stay out of YouTube jail. Next, we will seat the 68-pin PLCC socket. Again, we tack down 2 opposing corners of the socket so that we can inspect for fit. My music to solder to selection for the second portion of the build was Pink Floyd, Dark Side of the Moon. The ability to count is of fundamental importance. After cutting 2 5-pin edge connectors and doing a test fit, I realized I needed 2 6-pin connectors. If I save these connectors in my junk bin, I am guaranteed to never use them. If I throw them away, I will need them in my next project. Now we secure the edge connectors for soldering. As always, we check to ensure that the component makes a tight fit against the board. I will now solder in the 3 LEDs. In a slight derivation from the instructions, I will be using a yellow LED in place of orange, as it is what I have in stock. Also, I will be mounting the LEDs vertically, as I have no intention of putting this computer in a case. Pay close attention to the orientation of the LEDs, as the cathode, or short end, is toward the bottom of the PCB. There is likely also a flat edge to the LED denoting the cathode, although on mine it was very hard to feel the difference. Remember, only solder in one leg of the LED until we can test for fit. We are heading into the assembly homestretch now. We need to install a 6-pin female header for the SD card, 2 jumpers, a voltage supervisor used to keep the system inactive for a brief period of time after power is applied, a reset button, and the remaining capacitor. The instructions call for the SD device pins to be bent straight to allow horizontal mounting. We are going to ignore this step for now, as we will not need to fit this in a case. And in the future, we'll attempt to desolder and replace the pins with a straight variant. We solder in 1 pin for each jumper and the capacitor so that we can ensure that it is seated properly before continuing on with the soldering. We fit in the reset button, but the power manager will need some adjustment for the legs to get them to go into the holes. The voltage supervisor fits tightly, so I ignore my normal process for only tacking the first leg. However, we do want the reset button to fit tightly, so I do only tack one leg. Now to insert the ICs. I only have an inserter for the smaller ICs, so I will be using a circuit board fragment to help guide the legs into the sockets. The static RAM IC goes in the top right socket. Directly beneath that, I insert the flash memory IC that I previously prepared with the RomWBW firmware previously mentioned. The firmware link can be found in the assembly instructions of the SCC website. The 74139 is a 2 to 4 line demux. The 74259 is an addressable latch used as a register to persist 8 bits of data. Next, we insert the 18 MHz clock. The last IC we insert is the Z180 CPU. It is critical that you pay close attention to the orientation of the socket. In this case, align the flattened corner of the CPU with the flat corner of the socket. Please note that the CPU will appear to be oriented upside down as compared to the other ICs. Do not panic, this is correct. Before we can communicate to our new computer using a serial terminal on our PC, we need to connect the SC131 to a USB port on our PC. For this purpose, we will use a standard commodity FTDI adapter and connect the 6 adapter pins to the corresponding 6 pins on serial port A, the lower connector. This connectivity will also provide 5-volt power to the small computer. It is now time to cross our fingers and test our system. Stephen Cousins has provided excellent instructions, not only for the build, but also for troubleshooting. I'm going to jump right in and see if we can get this system to boot. We will set our serial terminal to the suggested 115-200 baud Z8 None 1 with hardware flow control and hit the restart. The restart shows activity on both the computer LEDs and the cursor is moving, but no output. To see if it is a comms problem, I will walk down the speed and reset at each step. 57.6, and we're getting garbage. I feel that's a good sign, at least there is life. 38.4, and different garbage. 19.2, and life. It seems to work fine. However, I noticed a few things that I will be researching later. The CPU reports as a Z180, and it is labeled as and should be a Z8S180. Is this a clue that my cheap from over the Pacific ICs may be relabeled? Too soon to tell. The clock speed is reporting 9.216 MHz. I believe this is the system responding to the fact that I may not have the proper CPU variant. Also, my SD card is not showing any capacity information. While we have the system up, let's quickly peruse some of the operating environments that come with the firmware. Two that jump out are CP/M and a fourth environment. Let's poke our head quickly into the fourth environment. Fourth is a stack-based language and as such can process reverse Polish notation like classic HP calculators did in the 80s. Here we push a 3 on the stack. Push another 3 on the stack. Push an addition operator on the stack, which will add the 2 3s and push the result of 6 back on the stack. Now we pop the stack with a period and see the result of 6. As fun as this is, most people will likely want to get to CP/M, so that's where we'll go next. RomWBW supports CP/M 2.2 directly. We can do a directory and see that we have Microsoft Basic. I can't be bothered to enter in a full hello world. Let's run CPU speed. Again, our issue is highlighted. The system has us in half speed, likely because of my CPU. I think I will go ahead and pay a few more dollars to get a Z8S180. But until then, it still works fine. I can get full use of the system, even at a slow clock. The issue with the SD card reader was in fact the SD card reader itself. Thankfully, when I ordered the part from Amazon, it came in a package of 2, and the second one worked straight away. Yes, I have to admit doubting my soldering skills, and I visually inspected every connection before breaking out the second device. Now you can see that the firmware recognizes a 32 gig card in the reader. I have loaded my favorite CP/M verification program onto the SD card from my Windows PC. Now we will move it to the CP/M operating system environment. I give this computer my QA Zork stamp of approval. A quick recap and reminder. This was not a vetted kit, but rather I assembled the computer successfully based on the clean PCB design, and I cannot overstate this. Excellent documentation by Messrs. Cousins and Worthen, as well as the active communities for each. As I am not a seasoned solderer, I attribute the fact that I needed zero rework to the well-engineered layout and great software. Also, thanks to the gentleman that threw in the empty PCB board with another order. I was not looking for another project, but you can't say no when an unpopulated board sits on your bench and stares at you in the face for many months. All issues that I experienced were due to components of questionable lineage from my spare parts bin, and even then, with the half clock speed, the system operates well. Check out the various websites and tell them the Mighty Pez sent you. Thank you.